As you remember from the previous video, our major goal is to build the autonomous ground rover with the ArduRover firmware on board. To implement this, we have to update our SpeedyB F405 flight controller with the ArduRover firmware, and now I am gonna show you how to do that. Okay, so to update our flight controller with the ArduRover firmware, we have to go to the official firmware ardupilot.org website here and find the latest firmware, and here we have to find our SpeedyB F405. Here, where we have it, mini, it's another one. Matek. Here. Okay. So we have it in here. SpeedyB F4 version 3. Our flight controller is SpeedyB F4 version 3 here, and everything we need, it's this hex ArduRover with BL hex file. We have to download it. It's already downloaded. Okay, now we have to go, we have it in here, ArduRover with BL hex 2.3 meters. Yeah, we go to beta flight configurator here, then we press the button on our SpeedyB F405, and in the same time put the USB device into the port, and here we have the FIU STM32 bootloader. So go to update firmware, and choose a board, SpeedyB F4 F405 version 3, doesn't matter. No reboot sequence, full chip arise. Load firmware local. Go to downloads, ArduRover with BL hex here. So it has 834536 bytes, less than 1 megabyte. And flash firmware, we have to click in here to flash our firmware. Arise in. flashing. So it is flashing now with an actual ArduRover firmware. Just have to wait for 1 minute or a little bit more. Very fine software which was flashed, and we have the success in here. So it's okay. Now we can reload. Yeah, in beta flight now we cannot connect because the firmware which was flashed to the flight controller is the different, and it can communicate with the software with a different protocol Mavlink either than the MSP protocol in beta flight for configuration. So we have to close this software. We have to go to mission planner, and in here, no, we don't want to update, and then here we have it in here, ArduPilots PDB. ArduPilots PDB. Connect, disconnect, disconnect. ArduPilots PDB. USB ArduPilots PDB. Honestly, I don't know why it has a problem here. Fail safe, and if I will move the rover, now it has a reaction in our mission planner. Okay, so looks like we did everything right. We really did it right. Okay, as we have our ArduRover firmware flashed on the ground rover, so now we have this software, and it's time for initial setup. In the book AI-Driven Autonomous FPV Drone Development, we have the comprehensive instructions, not only how to assemble this rover, but also how to flash here the ArduRover firmware. This step we already done, and the next one is the ArduRover configuration, and here we have everything we need for initial ArduRover setup. So I am gonna configure it now. To configure our ground rover, I am gonna use this electronic version of the FPV book, and here I have ArduRover configuration uh, section, and everything I need for the right configuration, it's this config section, full parameter list. So let's go to the book and we'll copy each parameter. Frame class is the first one. So we put cursor in here and frame class. Okay, by default it's the one, and because it's the rover, and we need its one. Yeah, frame type should be equal to 0, undefined. Frame type. Okay, frame type must be 0. It's 0 now. Yeah, looks like it's already configured. Mod PVM type is responsible for the type of the rover, as we have 4VD motors. We have to use in this parameter 4 brushed bipolar rover. So let's set up it into the brushed bipolar rover, which is 4. Mod PVM type should be equal to 4. After we changed each parameter, we have to write params. Parameter successfully saved. Okay. Reboot is required for some parameter to take effect. Okay. Okay. Must be rebooted. So yeah, here we have our USB port disconnected and now connected again. So I will reconnect after. Mavlink parameters, and we can check if our parameters are in. Mod PVM type is equal to 4. Yeah, looks good. Okay, the next one, servo 1 function 73 throttle left. For this, I prefer to go to the setup and mandatory hardware, and here we have servo output, and for the first one, servo 1, I will use throttle left. For the second one, I will use the throttle left again, according servo 1 function 73 throttle left enable reverse, so it must be reversed here. For the third one it will be throttle right, and for the fourth it will be throttle right reverse. As far as I remember, servo 3, servo 4, 74 throttle right enable reverse. Yeah, looks good. Looks good. Actually, we can check it in the full parameter list now. So servo function, servo function, servo function, servo function. Let's check it in here. Servo one function is 73 and servo one reversed is 0, which is not reversed. Servo second is 73 again, throttle left, and servo second reversed is 1, which means that it's reversed. The same for servo 3, which is 74 and not reversed, and servo 4, which is 74 and reversed. Yeah. So in this way, let's go to the setup again. And what we have in here, servo outputs are configured now. So we can proceed with other parameters. And another part which is really important here, it's a radio calibration, radio controller, and RC5 option 153. Switch to arm disarm, RC5 option. Let's actually check it with a radio controller. I will power on it now. Power on the radio controller to be able to bind with the rover.
Welcome to HTX.
Yeah, and after I powered on the radio controller, I can reconnect it to the Ardu Pilot software, and at the same time it will bind with the radio controller. It must. So we have to see in here, yeah. So now we can see here when I move the throttle up and down, we have an appropriate reaction in ArduRover, how you can see in here. So radio 5 is the tumbler which I usually use to arm and disarm. So now you can see radio 5 is 999, and when I push it, it's 2000. So we have to have an appropriate configuration. Let me check the roll. Roll is okay. U is okay. Throttle is okay. And pitch also is okay. Okay, so we can move again to the full parameter list, find here RC5, and assign for the RC5 option, RC5 option 153, which will switch to arm and disarm. So arm and disarm, arm disarm 153. Right, parameters in here, yeah. So now when we go to the data, we can see that it's disarmed, and I will switch the tumbler RC5 to arm position now. Yeah, pre-arm, compass 1 not healthy. So it failed to create log. ARM compass one not healthy. So we can't ARM because of different reasons, but it has an attempt. So now it's disarmed. ARM again. When I push it, compass one not healthy. Again we have the message in here, so it has an attempt had an attempt to arm, but failed. So at least RC5 now works for arming and disarming. Yeah. Okay, let's continue with our list. Arming check. Yeah, arming check temporarily disables arming checks. So the reason why we were not able to arm is the arming check, and now we will eliminate this obstacle. Arming check needs only for development reasons. Arming, 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 arming check, arming check. Arming in here. Okay. Arming options. We have in here arming options, but we don't have an arming check. Probably it's because this is a newer version of the software, and in my experimentation I had the same, I think 470, but arming check equal to 0 must be equal to 0. Arming options I see in here, but I can't find any arming check. Okay, let's arming skip check. Checks to skip prior to arming motor. I don't know. Probably let's go back to this little bit later. Yeah, RC7 option 55, switch to guided mode. Switch to guided mode, RC7 option. Okay, let's go to the RC7 here and find the option and 55. 55, which is 55, must be guided mode. So to be able to switch the rover to the guided mode, we have to somehow configure it in here. So now let's go to the main screen, and here I can switch into guided mode. As you can see in here, it's a guided mode now. I use the RC7 to toggle it into guided mode, so it will work in here. Let's go again to the config. GPS one type equal to 2 U blocks. Actually, we will not use any GPS. So we can, I think GPS one type. We can go to GPS one, and set it into none. So we are not gonna use the GPS at all. Write parameters here. The number of available parameters change. A full parameter refresh will be done to show all parameters. Yeah, I agree. GPS type equal to none. Arming check. I'm surprised because of arming check. It's not here now. Okay, so let's go to another parameter. Serial 1 baud rate is 38,400 baud rate for GPS module. EK3 GPS check disables GPS check. Okay, let's go to EK3 GPS check. GPS check should be set to zero. So I think it will be zero. Yeah, this is zero. Write parameters in here. Okay, serial for baud rate. For telemetry module we will set up a little bit later. Serial for protocol mavlink as well. Actually, we have in the setup tab here is the serial ports, and each parameter regarding serial ports we can configure in here. So for serial port 4 we have to set up 57 the baud rate, and the mavlink protocol, mavlink second one is, which is here. So, and another parameter VP speed equal to 0.5 limits rover speed to 0.5 meters per second in guided mode. So let's set up this parameter also. VP speed 0.5 0.5. Okay, right parameters saved successfully. And I'm still wondering why we can't find an arming check. Probably the arming check moved to some another parameter. Checks to skip prior to arming motor. This is bit mask. Bit mask of checks before an arming that will be skipped. For most users it is recommended to leave this at the default of 0, no checks skipped. In extreme circumstances, a value of -1 can be used to skip all non-mandatory current and future checks. Armin skip check. Probably checks to skip prior to Armin motor. This is a bit mask of checks before allowing Armin that will be skipped. RC channel, GPS log, probably barometer, compass. We can skip GPS log, board, battery level, login available, hardware, safety switch, GPS configuration, mission, rangefinder, camera, aux, visual odometry, FFT, I don't know what does it mean. Okay, probably like this. Armin skip check, Armin router, Armin require, Armin disables until some requirements are met. Armin require after minimum PVM when Armin options set bit mask. Okay, anyway, the initial configuration I think is finished, not ready to arm. In here we have it's because of battery level, because GPS satellite count is equal to 0, but anyway, first powering from the battery pack will be a little later in the next video, and even in this configuration it must work at least in manual mode. So the initial setup for ArduRover, for our ground rover, is completed now, and this is just the first step. And in the next video I'm gonna proceed with powering this rover with the actual 14 volts from the battery pack. So it's gonna be very interesting.